Okay, so let's take a look at an example where we calculate a line integral with respect to arc length. So it doesn't state specifically, but you can tell because looking at the way this line integral is set up, here you have a function of f of xy, actually f of xyz, so this is a 3-variable function, and here the ds represents arc length. Okay, so so we're asked to calculate the line integral over the curve C, which is a line segment from the point 0, 1, 0 to the point 3, 2, 5. Okay, so first we need to parameterize this line segment. So using the formula from the previous page, we have that r of t is going to be x1 plus x2 minus x1 times t, and then the y component will be y1 plus y2 minus y1 times t, and then the z component will be z1 plus z2 minus z1 times t, where the coordinates are exactly the coordinates of these points, right? So this is x1, y1, and z1, and this is x2, y2, and z2. Okay, so let's calculate this, right? So the x component will be 0 plus 3 minus 0 times t. The y component will be 1 plus 2 minus 1 times t. And then the z component will be 0 plus 5 minus 0 times t. So simplifying everything, what do you get? So the x component is 3t. The y component is 1 plus t. And then the z component is 5t. Okay, so let's just make a note again that for this curve, this is the x component, this is the y component, and then this is the z component. Okay, so before we calculate the line integral, we're going to involve the arc length component, right? So so we need r prime right, so this is so the derivative, so that's 3, this would be 1, derivative of the z component will be 5, right? So this is x prime, y prime, and z prime. And then the arc length component involves the magnitude of r prime, right? So let's calculate that. So it's just the square root of x prime squared plus y prime squared plus z prime squared. So in this case, it's going to be square root of 3 squared plus 1 squared plus 5 squared. So what is this? This is 9 plus 1 is 10. 10 plus 25 is 35. Okay, so that's the square root of 35. Okay, so now we're ready to set up the integral, right? So we have a function of 3 variables, right? So we're integrating over the curve C of f of x, y, z with respect to arc length. And so the way we set up this integral is we've already parameterized the curve, right? So the variable t goes between 0 and 1. So right, because that's how we parameterize the straight line. We interpolate between the 2 points where t goes between 0 and 1. So we integrate from 0 to 1, and then we have to plug in x, y, and z into the function, right? So what was the original function? The original function was xz, right? So what is the x component? That's 3t. The y component is the z component, right? It's x times z, so the z component is 5t. And then ds is the square root of this is the ds is basically just the magnitude of r prime of t dt, and so so we get the square root of 35 dt. Okay, so this is what we have to calculate. And so what do we have? 3 times 5 is 15. So you get 15 square root of 35. That's just a constant multiple, so we can pull it out of the integral. And then we have the integral from 0 to 1. T times t gives me t squared. So the antiderivative of t squared is t cubed over 3, evaluated from 0 to 1. And so if you plug in 1, you get 1/3. So that's 15 thirds square root of 35. If you plug in 0, you get 0, so that cancels everything out. So this is the value of the integral. So you get 15 over 3 is 5. 5 square root of 35. If you want to calculate this in decimal form, 5 square root of 35 is equal to 29.58. Okay, so that's how we calculate this kind of line integral. So in this example, we had a function of 3 variables, and the line segment is connecting 2 points in 3-dimensional space. But the setup is similar whether you're working with a function of 2 variables or whether you're a function of 3 variables, right? So you just need to set up the integral appropriately. And in the end, to calculate these line integrals, the integral that we set up ends up being an ordinary integral. So you just use the ordinary methods of integration to calculate once you've set everything up like this.